All right, so here we go. The learning targets are on there, so you're all good there, so no issues. Just make sure you're keeping track of what you're struggling with, and hopefully we'll have an idea of how to get you where you need to. This is the last test of the quarter, as usual. You're going to want to do really, really well. The summative is going to look very similar to this, so if you can do the things that are on this, you're going to be able to do the summative as well. So number one, learning target one, obviously solving one-step equations. That's what learning target one is. Okay, what's the first step that we have to do here? We have to draw the line. So I'm going to have to draw my line. That's something that I've told you I want done. Okay, now we always ask what? And we can write this so we all know. What? Yep, Olivia.
What is happening to the variable?
What is happening to the variable? Let's everybody write it right now. Just so we have it. Because this is now, remember this formative is now your study guide. It's exactly what it is. What is happening to the variable? Okay. Now the idea is you want to answer that question, what is happening to the variable? And what is happening to that variable? Isabel?
It's being added.
Or you can take 4/5 as being added to it, right? But you could say it's being added. Same idea. Okay? So how do I undo adding 4/5? I need to subtract 4/5. So here we go. Now you could write it right here like this. Or you could have written it up here horizontally. I don't really care how you did it. Doesn't matter. On the left side, obviously the whole point to undoing or using inverse operations is to do something called isolating the variable. Which when you isolate the variable, that means you have one of the variable, so you're going to figure out what m equals or whatever the variable is. So what was cool about, or what was easier about this question? What was maybe easier? Yes? They already have the common denominators. Can you expect that to happen every time? No. So you just got to understand, if this was 4/3, something like that, you would have to do common denominators. Okay, so we know that when you subtract fractions, you only subtract the numerator, so that's 3, and then the denominator stays the same. There's my answer. Am I done? What is that final step? Very important. I'd like everybody to write this. Final step. Realistically, nobody in this room should have missed this question, but I know people may have. I know a couple people did for sure. This final step should be your own personal check. This should be your way of knowing whether you got it right or wrong. There's no way not to. What is that final step? Yes? Plug it in. By the way, also called the, you know how we've learned about the commutative property? We've learned about the distributive property, right? Well, here's another one that you've been doing for a long time, but it's called the substitution property. The substitution property is just when you say, if I gave you this, and I said when x equals 2, you're going to take it and plug it in. That's called the substitution property. So it's kind of a silly thing to even think about, because you already know that you can do that. All right, so we're going to plug this in now. And, you know, I really suggest actually writing the problem. So I'm going to take that 3/5, and I'm actually going to take it and plug it in. So I'm going to do 3/5, and I'm going to add 4/5 to it. My denominators are the same. I get 7/5, which is the only answer that I could have gotten, right? So nobody in this room, if you missed it, I guess be mad at yourself a little bit, unless you just didn't know how to do it. That's different. But if you just made a math error, like you just subtracted, or maybe you added and maybe you did 7 plus 4 and got 11/5. That's a common mistake that people do. They add them, you know, and that stuff happens. I do that stuff as well. Okay, so don't get too stressed out, but you got to make sure you're checking that. Okay, next one. Okay, we're going to be drawing our line. First thing we're going to do, then we're going to ask, what is happening to the variable? Well, we know that the variable 1/8 is being taken from it, or I'm subtracting 1/8 from it. Okay, so now I'm going to undo that by adding 1/8. Adding 1/8. And like I said, same thing here. You can write it right there. I mean, you could go off to the side and rewrite it over here, 1/2 plus 1/8. Some of you do this all different ways. Some of you show it right in here. Some of you rewrite it. I don't really care. What work do you have to show me here, though? You have to show me common denominators. If you didn't, it's incorrect. Okay, it's incorrect. You can't get it right unless you showed your common denominators. I'm not only... I've said write it about 3 or 4 times now, and you've only written 1 of 4. I'm not going to remind you again. Okay, you got to show me the common denominator. So we know that what would be a good common denominator to use here, Ava?
80.
8 would be perfect. Could I also use 16? That would be the QCD, the quick common denominator, but I'm just going to use 8. And then I got to do whatever I did at the bottom to the top. Now I'm ready to go. I get 5/8. So you could have done that, all that work right here. I don't care. Regardless, we learned that m equals 5/8. Am I done?
No.
What's that final step that I always need to do? And it's just going to help you guys. It's going to help your grade. Trust me. Yes. Plug it in real quick. Just come up and look. The denominators are already the same. You're doing 5/8 minus 1/8. The denominator. So it's real easy. You get 4/8, which you'd have to what? Simplify, and that would give you 1/2. Like I said, I get it, guys. There are times when you're doing this where you subtract 1/8, or you just make a silly mistake. That stuff happens. That extra little final step right there will save you. Trust me. All right, number 3. Here we go. This is the one that's been throwing some of you off. First of all, obviously, you draw your line. Okay? Now, a lot of you get confused on whether you're multiplying or dividing here. So I still have some people trying to multiply 3/4 to both sides. Remember, it's all about what is happening to the variable, not just what is happening to the 3/4. Yes, that is 3 divided by 4. Does everybody agree with that? But is that what's happening to the variable? No. We're asking what's happening to the variable, and that's just a coefficient, 3/4. It's just not a whole number. It's no different than 2k equals 10. Right? It's the same thing, only it's a fraction. So we need to undo that by using what operation? Quentin?
Division.
Division. So I'm going to divide by 3/4. Now this is the one that I said it's not a bad idea to just kind of write it off, or like do it right here. Now I don't have a lot of room. It's probably easy for you guys to make room. But you could have written it right there, or you could go off to the side and do 9/1 divided by 3/4. Regardless, I need to see the algorithm happening here. If you didn't show this, it's wrong. The dividends staying the same, divides becoming multiply. The reciprocal of 3/4 is 4/3. Can I cross simplify?
Yes.
Yep. I can divide a 3 out of those diagonals right there. So I did 3 divided by 3 is 1. 9 divided by 3 is 3. And I end up getting 12/1, which we know equals what? 12. So basically this work right here, this could have happened on the side, could have happened anywhere, but I had to see this work. Not the cross simplifying. You don't have to do that, but you have to show the algorithm happening, like the reciprocal and all that. So we learned that k equals 12. Am I done? Nope. Now I need to plug it in, because that's going to save me. So I know it's going to be 3/4 times 12/1. Okay. Now you could cross simplify here if you'd like. Doesn't really matter. Okay. If I did do that, I see that 12 and 4 have a common factor of 4. So if I divide out that 4, I get 1 there. I get 3 there. I get 9/1. Is that what we had to have it equal? Yes, I did. All right. So I went pretty slow on those because I wanted to make sure we were all good on work and expectations and plugging it in, all those things. Okay? Yes?
This is from the common denominator.
Hey, that's the only thing that'll mess you up on this. Like when you first did, if you actually did 9/4 times 4/3, you would have gotten 36 what?
Yeah, the bell.
30, listen, if you actually did the algorithm and didn't cross simplify here, you would have gotten 36/3. If you plug 36/3 into that, it will give you 3/4. Okay, that's the only issue. But you guys got to know that we always simplify fractions, which shouldn't be that difficult because you have a calculator. So you can use that method to kind of always just quickly confirm it. All right, let's go on. Number 4. Okay, we're talking about the inequality, m being greater than 15. So right away, based on that alone right there, what 2 answers can I eliminate right away? Okay, well I guess you can look at it 2 ways. I thought about it as open dot, closed dot, but I see you guys are kind of saying, because you're saying it's m greater than, so you're eliminating the ones that are shaded to the left. I always say start with the dot. You guys can do it however you'd like. You can do it however you want to think about it. But I think it's easier to think, okay, I know that somewhere right there doesn't have an or equal to on there. That's going to be an open dot. So I'm going to right now eliminate both B and D. Remember, it's all about finding the 3 incorrect answers, which will lead you to the correct answer. Okay? So now I know that, maybe some of you understand how to read this. It's trying to eat the variable. So we should know right away that we are talking about solutions being greater than 15. But let's never just assume. Obviously, it's not that one. It's going to be A. But here's the deal. Once you get done, let's do that final step again. Let's all write this. Final step on these. Let's just plug in a number. Plug in a number. Just quickly do it. It'll take a couple seconds. Okay? And all you have to do is pick a number in the shaded area. Like for instance, let's do this. Let's say you thought it was letter C. You thought it was C for a minute. And you said, all right, I'm just going to plug in 0. Because 0 should be a solution. And if you put 0 in there, is 0 greater than 15? Is it trying to eat the bigger number? So if you do that final step, once again, you're going to catch yourself. So then you're like, oh, wait a minute, I think it's A. That's not the answer. And then you say, okay, I'm just going to check 20. And then ask yourself, is 20 greater than 15? Yes, it is. So I checked it. Letter A. Everybody got that? Cool? All right, number 5. Write an inequality for the situation. There are at least. So I'm just going to start here. I always start like this whenever I teach this. If you'll remember from the video, I always start with my variable and then 62, whatever the number is. And I start looking for words. When I see words like at least, at most, you might want to write these. Maximum, minimum. All those words right there, I know it's either going to be greater than or equal to or less than or equal to. Everybody got that? I know it's going to have the or equal to. Okay? Everybody got that? Ava, I just said write something. Please. Okay? So, you know whenever you see those words right away, you know it's going to include that number. So 62 is included here. So because of that right there, I'm going to go ahead and put that line there. So now I can go ahead and eliminate both letter A and letter C, correct? Because I know it's got to be 62 makes this true. So now it's all about figuring out at least. Okay, what does at least mean? Does that mean 62 or more? Or does that mean 62 or less? It means 62 or more. So what I'm going to do is I'm going to make that greater than or equal to, which is going to make it letter D, which eliminates B. But let's always just do that final step once again. Quickly think about it. There are at least 62 children in the classroom. How many students could be in the classroom then, guys? 62, but how many? What else? How about 63? There could be 63. Does that make that true? That's my check. Everybody got that? Okay, let's go on. Okay. Next one, right? The inequality shown. So we see that they're all M's. Based on that dot right there, what two answers can I eliminate right away? Both B and D are gone. They're out of here. Those are not going to help us anymore because we know a closed dot has to be either greater than or equal to, or less than or equal to. Okay, it's one of those two. Now we're talking about solutions less than it. So we know that the solution should be, the inequality should be trying to eat the actual number. So it should be letter C. But once again, final step, just pick something. Give me a number in that solution set. Lucas, sit up. Yeah.
It's A.
Yeah.
I'm sorry, A, that's what I meant, sorry. It is A, my bad, sorry about that. Okay, but give me a number in that solution. Give me a number that I can choose to plug in.
1, 2.
1 or 2 or 0, doesn't matter, I'll pick 1. If I take 1 and put that right there, is that a true statement? Yes, it is. So that's the always little check I want you to do. Okay? Number 7, which steps should be taken to isolate the variable in the following equation? Well, if you drew a line, you'd ask yourself, what is happening to the variable? You would say it's being multiplied by 9, and then you would say you have to divide by 9. Right? Letter D. Number 8, here you would draw your line. Now you'd be saying, okay, 4 is being added to the variable. Okay, so we need to do the inverse of adding 4, so that is subtracting 4. Go ahead and put what you got out of 8 at the bottom. What? Huh?
Learning target was 7.
It says it on there, doesn't it?
Number 1. No, we don't have it on 6, 7, and 8. Or 5.
Oops, sorry about that. Alright, okay. Learning targets are on there. Sorry, I don't know why they didn't. Oh, I know why. Your class didn't. Everybody else's class did. That's why. So I'll try to slow down. Okay, up here. These are all learning target number 1. Now, here's the deal on these. Pay close attention. you had to prove all of these. So there's two ways to prove it. I'll show you both ways, okay? So everybody stay with me. I'm going to show you both ways. But you had to write it out. So the first method, so I'm going to call this, I'll take number 9 over here. And this over here will be method 1 over here. This over here, I'll show method 2 over here. This will be method 2. So you can write, if you don't have the other one, you can write it if you'd like. I don't care. Method 1, the first way that you can do it if you'd like, is you can simply solve the equation. So I'm going to rewrite the equation. And I'm going to say what is happening to the variable. Okay, it's being multiplied by 4, so I'm going to divide by 4. Divide by 4, I'm going to learn that m equals 5. So right there, I just proved it true. That's method 1. So if I'm talking about method 1, that would be just to solve. Just to solve it like you normally would solve any equation. Got me? That's method 1. Now over here in black, I'll do method 2. Method 2 is just plugging in. We got that? Those are your two methods. You had to do one or the other. So if I'm going to do this, what I'm going to do is I'm going to take 5 and I'm going to plug it in. And I'm going to rewrite it 4 times 5. Now, is 4 times 5 20? So I just confirmed it true. That's the two methods. If you did no work, it's wrong. If you showed nothing, it's wrong. Even if you did 4 times 5 in your head. I told you I wanted you to prove it. I made that clear. Okay? Next one. Once again, over here, I'll do method 2. Or method 1 over here, I'm sorry. And that is going to be, okay, so we have the equation m divided by 6 equals 24. So I'm going to draw my line. I'm going to multiply by 6 to both. And I'm going to get m equaling what? 144. Is that what it's supposed to equal? Okay. So right there, I just proved that this is false. That's one way. Over here, I'll do method 2. Okay, I'm going to take 4, and I'm going to plug it in. 4 divided by 6, well, it's not that. Okay, it's not that. It's going to be 0.6 repeating. Okay? Everybody seeing the understanding the two methods? Pretty easy? Okay? Number 11. M minus 3/4 equals 5/4. So I'm going to draw my line. I'm going to add 3/4 to both sides. And I'm going to get m equaling what? 8 over 4, which equals what? 2. Is that what it's supposed to equal? Huh?
Yeah.
Okay, good. So that's the first way. So right there, I just proved it true. Now over here, what I'm going to do is I'm gonna plug it in. Okay, so I'm going to get 2 minus 3/4. And that would be obviously 2 over 1, right? You'd make this 4. You'd make this 8. You're going to learn that it is 5/4. So right there, we just proved it in two methods. Okay. Number 12. We have m minus 8 equaling 12. Draw our line, add 8, add 8. We learned that m equals 20. Is that what it's supposed to equal?
No.
Nope, so there's false. The other way, well, if you take 4 and plug it in, 4 minus 8, that certainly doesn't equal 12. It equals actually negative 4. But you didn't have to know that. You just had to know that it didn't. Where's your learning targets at? I don't even see anyone on the 10. So I'd like you to explain to me how that's correct. You didn't get it. How many times are you going to ask me? It's wrong. Count it wrong. Okay, over here, this one, we got number 13. We got m plus 2.1 equals 4. Solve it once again. 2 minus 2.1 minus 2.1. We're getting m equals, what is that going to be? 1.9. Is that what it's supposed to be? So obviously false. The other method, obviously taking this and plugging it in and doing 6.1 plus 2.1 equals 8.2. And there you go. Obviously that would make it false, right? So, you know, you only had to show one of those two methods, but I would encourage those two methods, or, you know, obviously you had to show at least one of them. I mean, that's just simple, plain and simple. If you just circled any answer, or you just circled true or false, it doesn't even matter if you got it right. Does everybody understand me? It doesn't even matter if you got it right, because on the summative, if you just circle true or false with no proof, wrong. Yeah.
Does that count as
Learning target.
Guys, those are all learning target 1. Anytime we're solving equations, guys, we're talking about 1. This is going to be, so this is 5 different, 1, 2, 3, 4, 5 different points there. Okay? All right, let's go on to the next little set here. These two, you have to have work. Now, these are learning target 4 on these. Okay, so it's right there. Okay, you had to have work. So the work that I showed and that you had to show was I actually came down here in this blank space and I rewrote them. P plus 5 greater than 12. If you tried to squeeze it in up here, that's fine, as long as you showed the work that I'm about to show. So we're going to solve inequalities the exact same way we solve equations. We're going to do the inverse operation. We learned that that's going to be P is greater than 7. Okay? Because here's the thing. I just want to show you this real quick. This question was actually very easy. Because couldn't you have just looked at the inequality symbols and kind of just like said, okay, less than, less than. You guys see what I mean? Yeah. So if you did it that way, it's wrong. You had to show me that you understand how to do the skill. So right there, I learned that that's going to be letter D, right? Okay, number 15, we're solving that inequality. B, sorry. Number 15, okay, we got P minus 8 less than 9. We draw our line, we're going to add 8 to both sides. That's going to be P less than 17. Okay, so obviously that's going to give us letter D. Okay, number 16, 3P less than or equal to 21. Draw my line. Remember, you had to have all this work. If you didn't, it's wrong. P less than or equal to 7. Okay, and that's going to be letter A. And then number 17, we got P over 3 greater than or equal to 7. We draw our line, multiply 3 to both sides. We learn that P is greater than or equal to 7. Okay, and that is going to be, what, letter?
It's 21.
Jeez, my goodness, I'm off my game today. All right, here we go. 21, C, there we go. All right. What? Did you solve it or not? Well, you had to do it like this. That was really your only options here because...
Plugged it in. Yeah, I plugged it in.
Guys, but that doesn't make any sense.
Yeah, I got
Because,
the right
like, if you,
answers.
okay, but if you take B and you take 7 and plug it in, 7 plus 5 is not greater than 12. So,
No.
all right, I'll accept it. If you just looked over here and you said, I didn't want you guys to do it that way. Because here's the thing. I mean, that's great, but the skill here is being able to solve these. I mean, on the test, on the summative, I might not give you answer choices, so I got to know you got to know how to do this. So if you knew, okay, I know that 8 is greater than 7, and I guess you plugged it in, I guess I'll accept it, but just understand that they're not always going to be giving you this. It's 1 point each on those, so that's out of 4, so that's 4 checks or 4 X's. Okay? Number, go up here to the top right, number 18. Okay? Which inequality best represents this situation? Well, right there, when I see that word right there, I know that that's one that would be what? Have or equal to on it. So right away, I'm going to eliminate both A and B. Whenever we see at least, at most, maximum, minimum, this, like 20 or more, something like that. When you say it like that, it's going to be good. So if we're saying a number is at least 20, that means that it could be 21, could be 24, could be 30, right? So we know it's going to have to be greater than or equal to 20, so letter C. Okay? Okay? A red block and a blue block are on a scale. The red block weighs 5 ounces. The total weight of both blocks is at most 11 ounces. Select the inequality that best represents the situation. So you all knew it was going to be B plus 5 and 11, right? Because you're saying that the red block weighs 5 ounces. We don't know how much the blue block, that's why we have a variable. And then we know they both weigh at most 11 ounces. So right away, what 2 answers can I eliminate from the multiple choice? B and C are off the list. They're gone. We don't have to worry about those because we know at most would represent that an or equal to inequality. Okay? So, at most, does that mean it could be less than 11 ounces? Sure, so it would have to be less than or equal to 11 ounces. Everybody got that? Everybody understand that? It's not going to be greater than or equal to, because that would be if it was at least 11 ounces. It could be 11 ounces or more. This has got to be 11 ounces or less. Okay? Number 20. Okay? Which is not a solution. I said you guys had to prove this one. So you had to show a little bit of work here. Now you guys kind of struggled with this one. Now, the way that I thought, and you might want to write this if you didn't do this, this is the way I thought a lot of you would do it, but a lot of you were doing it differently. You know, anytime you're given an inequality and you want to figure out what's the solution, what's not, rather than take all these and plug it in, which, how many of you did that? How many of you just took all these and plugged them in? I just feel like that's going to be harder. Plus, you're just, and that's okay that you did that, but just keep in mind, on the summative, this might not be a multiple choice question. So you're going to have to, well, I guess it has to be because it's which is not a solution, but why not just go over, and like I said, if you didn't do this, just do it now, write it on your paper. Draw your line, say, okay, x is being divided by 3, so I need to multiply by 3. I'm going to do x greater than or equal to 18, right? And then I'm just looking at, I know that, is A true?
Yeah.
Yeah, A is true, so that means it's wrong. 24, is that true? Okay, so that means it's wrong. Now, 30, is that true? Yeah, so that means it's wrong. 9, is that true? There's your false one. That one's not a solution. So even though some of you, I understand you plugged in 9, you said 9 divided by 3, that gives you 3, and 3 is not greater than 6, that is false. That's fine. Just understand, when you guys have this skill to understand how to solve equations and inequalities, that's going to help you the most on this. Did you write what I just said right? Where'd you have it? Oh, there's the 4th time. I've had to remind you. Okay. Mr. Gellenbeck earned $4 an hour. Last week he made more than $80. Select the number of hours that Mr. G could have worked. Right? So, I'm not going to... Really, I wanted you to write an equation here. How many of you wrote an equation? How many of you did? If you didn't, do it now. Because it's pretty easy. It's pretty easy. Okay? If you know that Mr. Gellenbeck earned $4 per hour, wouldn't the amount of money he made be represented by 4H? Right? Okay? And we know that he made more than $80, so wouldn't that be greater? I guess I shouldn't have wrote equation. That was wrong. Inequality is what I meant to write. Sorry. How many of you wrote an inequality? Okay, there we go. Okay, so when you 4H is greater than 80, now you just go ahead and solve it. Divide 4, divide 4. You know that Mr. Gellenbeck worked something greater than 20 hours. Now, more than half, I mean, I bet you 75% of the kids that I taught missed this question. Because you guys saw this and you said, oh, well, he could have worked 20 hours. That is wrong. That is wrong. Does 20 make this a true statement, guys? No, it does not. That is incorrect. This was the biggest distractor out of those answer choices. A lot of you chose B. It is not B. Okay, I know that a lot of you said, well, wait a minute, but Mr. Garrison, 4 times 20 is 80. And I said, absolutely. If he would have made exactly, I didn't want to take all that off. If he would have made, last week he made $80, the answer would be letter B, correct? But he didn't just make $80. He made $80 and 1 cent, right? He made $80.20. Does everybody understand that? So no, he couldn't have worked 20 hours. Obviously, he couldn't have worked 10. That would have only put him at $40. Clearly, he couldn't have worked 18. The only one that he could have worked would have been 25 hours. Yes? Yeah, sure. Okay, everybody got that one? That page out of, what is it, 5, 6, 7, 8, 9, 10, 11, I got 12, am I wrong? 5, 9, 13, you're right, okay. 13, there we go. Go on to the next page. Okay, this too had to be proved, guys. Now, if you didn't do it this way, it's wrong. You had to show your solving of these. You had to do it. If you didn't do it, it's wrong. All 4 are wrong. Okay, so I had to, first of all, draw a line. I needed to then divide by 5. Divide by 5. I learned that x is greater than 3. Now I'm going to match that to the correct line. So the only one that's going to make sense would be letter B there, right? This one, I draw my line. I'm going to multiply by 3. Multiply by 3, I learned that x is less than or equal to 3. Okay? Less than or equal to would mean that it's either going to be A or C, and it's going to be letter A. Okay? Here we have x plus 10 is less than 13, so I'm going to subtract 10, subtract 10. I learned that x is less than 3. And that is going to be an open dot, and that's going to be letter D. 25. I'm going to add 2. I'm going to add 2. That's going to be x greater than or equal to 3. And that is going to be letter C. Once again, guys, if you did not show this work, it is wrong. It's wrong if you didn't solve it. That's the only way you could do it. All right, so checks and X's, Y's here. Okay? Learning target 4 is solving. So here's my thing. If you solved them all correctly like this, give yourself 4 checks on learning target 4. If you matched it to the correct inequality, give yourself 4 more checks. Is that easy enough to understand? Okay? Everybody good then? Okay. Here we go. 26. After Caleb spent $5 of the money he earned for mowing lawns, he had $15 left. Let M equal the amount of money Caleb earned mowing lawns. Write an equation. So, if I know that this is how much he had when he started mowing lawns, he spent 5 of it, that is the equation that you have to have. And you did not have to solve it. Okay? He started with this for mowing. He subtracted the $5 that he spent. He's left with 15. So if you were to solve this, you would solve it like this, and you would get M equals 20. You did not have to do that. All you had to have was the actual equation itself. Okay? Next one, number 27. Jack had 4 times as many cars as Gwen. Jack has 24 model cars. Let M equal the number of model cars Gwen has. Write an equation to represent the number of model cars Gwen has. Well, here we know. If we know that Jack has 4 times as many, and Jack has 24, isn't that going to be 4, what is it, what variable? 4M equaling 24. Right, guys? Good. Okay, you did not have to solve. Okay, down here, this question right here is the actual question. This up here is just information. It said, if Marcus is X years old, his brother Tony is 5 years older than he is. Okay, so if you ever want to figure out Tony's age, wouldn't you be just doing X plus 5? And wouldn't that be equaling, in this case, Y? Right? That's it. X plus 5 equals Y. What? Or you could write Y equals X plus 5. Y minus. No, because when we did these, did we ever have X equals something? No.
X is Mocus.
No. Look, it's always equals Y. Okay, this is what we talked about the day that I was out. It was always Y equals something. Everybody got me on that? So it's wrong if you did not have that. This is the only thing I'm accepting. It's all about the independent and dependent variable, which we'll talk about here in a minute. Okay? Now, if Marcus is 12 years old, then how old is his brother? Well, what is it going to be? What is it?
17.
17, you got it. Well, guys, listen. If you did Y minus 5 equals X, that does give you the right equation. But you guys got to understand, whenever we write linear equations, it always has to be Y equals. That's what we talked about. That was the whole point. Remember the whole thing when I was out on Wednesday? And we talked about how it's Y equals X plus 5 because this is your independent variable, this is your dependent variable, right? We talked about it. I didn't talk about independent dependent because I was going to put it as a bonus. Yeah.
I didn't have the equals Y part.
What's wrong? Okay, number 30. Right here. Write the inequality shown by the graph. Okay, I don't care what variable you used. X, Y, M, R, doesn't matter. Okay, I know that it's a closed dot, so it's going to be or equal to, and that's obviously -3. And that's shading solutions greater than or equal to -3. You could have also written it like this. It's fine. I always put the variable on the left. Most do. Some of you like to put it on the right, which is fine. Okay, these are with 2 points. write an inequality for the situation that's shown. More than 31 binders in the tray. So once again, just pick whatever variable you'd like. And 31. If we're talking about more than 31, then we'd have to do that, right? Or you could have written it as that, once again. Okay? Plot the inequality on the number line. Okay? So I always told you to do the number and its opposite. I know it's going to be an open dot on 31, and my shading is going to go to the right. Okay? Everybody good on that? That's going to be 4, 5, 6, 7, 8, 9, 10, 11. Right? Back page. Okay. This one here is just going to be worth 1 point. It's either all right or all wrong. The first thing you had to do, you had to solve all these. If you didn't solve them, it's wrong. Had to solve them. Okay? So, we know that 5 is being taken from x, so we're going to add 5. Add 5. That's going to be x equaling 7. Here, I know that 7 is being added to x, so I'm going to subtract 7. That's going to give me x equaling 5. Here, I know that x is being multiplied by 3, so I'm going to divide by 3. That means x equals 2. And here, I'm going to be multiplying by 3, and that's going to give me x equaling 36, right? So, now I have what x equals in all those. Like I said, you had to show this work. If you did not, it's wrong. And this same exact thing will be on the summative. So, if you didn't have it, you may want to write it. But you had to have it. Okay? So, if those are all your solutions, you just had to figure out which equations, and some people were doing this, like putting A, B, C, D like this. That's fine too, and then putting it in there. Is that solution going to be less than 5, or is 7 less than 5 or greater than or equal to 5? So that's going to be x minus 5 equals 2. That's the first one, or you could put A or something like that. Okay? For letter B, we know that x equals 5. Okay, so is 5 less than 5? No, it is 5 is greater than or equal to 5. So that will be x plus 7 equals 12.
We need your help. You gotta go. Yeah.
Okay, you got to give me a second. Hold on 1 second. I'm coming. Okay, next one. We have x equaling 2. That's going to be less than 5. So 3x plus 6. I'm sorry. 3x equals 6 is going to be on letter C. And then finally letter D is going to be greater than 5. So that's going to be x divided by 3 plus, no, equals 12, right?
Yeah.
So letter D. So there's your points there. All right, last one. Okay, identify the independent and dependent. This is just worth 1 point. So if you get 1 point here, you can add it to your total. Okay. Yep. But it's that you can't get half for anything. It's either right or wrong. Okay. All right. Now this is what I was telling you guys. This is how we write linear equations. We talked about this when I was out. Okay, or I talked about it on the video. A linear equation, which you don't understand right yet. You do understand it's a line. You all remember that, right? A linear equation is a line. Okay, you're going to learn how to graph that line in 7th, I think, maybe more so 8th grade, but a little bit in 7th, I think. Okay, you don't understand that yet. But what you do have to understand is did you learn independent and dependent variable in science?
Yes.
Yeah.
Good. Okay, the independent variable, that's the one that you're choosing. So basically, when we did that Marcus question, okay, we are saying that Marcus's age, that's the independent variable. Okay, that is the independent. Okay? Because that's the one that you're choosing. Whereas the dependent, and I know this is probably how Mr. Glassburn taught you, it depends on what the independent. So no matter if I change x here and make it, okay, he's 8 years old, is that going to make a difference on this y? So whatever you do to x, it's going to affect the y. That's why your x is the independent, your y is the dependent. So this page, listen, is only out of 1 point. But you could have, listen, you could have gotten either a 0 out of 1, a 1 out of 1, or you could have gotten a 2 out of 1. You guys got that? Because you get that bonus point if you did it. Okay, so this whole entire test is going to be out of 12, 25,
What's the first page?
25.
You got this one right. This one's so right.
33.
This is the right answer, so it should be right.
Missed
No.
you. Okay.